It's so nice to welcome you all to this launch of the decision support tool from the Horizon 2020 project S2S4 Today we are launching the beta version of the tool, and we'll come back to you later on why we call it that. I think that the rapid changes we see makes the need for more climate services and more precise climate services just more and more important. And I also think it's really nice, what's really nice in this project is that we're actually launching a tool in the middle of the project and not in the end of the project. And we will come back to the reason why we do it that way and why we don't, do the research for 3 years and then launch a tool. But I'm not an expert on this. I'm just here to make sure that everybody gets to speak and that we will be more or less on time during this event. So I would like to invite the following people to the floor to explain us a little bit more about this tool and how this tool came to be developed. So I would like to invite Albert Soré Miravet, who is the head of the Earth Systems Science Group at Barcelona Supercomputing Center, BC3 for short. He's also the project coordinator for the whole S2S4 project. And I would also like to invite his colleague from Barcelona Supercomputing Center, Isadora Jimenez. She's what we will call a science communication expert. And she's also been involved in the user engagement as well as actually developing this tool. Then we have Mathieu Salel. He is a power engineering specialist in energy climate issues. He worked as an innovation strategist at LGI. LGI is a consulting company that is specialized in sustainable innovations. And last but not least, we have Christoph Elsasser. He is a senior analyst at the energy methodology at the trading department at ENBW. And you can do the German version of that if you like.
Yeah, and it's Energie Baden-Württemberg.
Thank you. And he's also part of the S2S4 project. But first, I would like to start with Albert, because Albert, you're the head of the whole project. And how did the journey of this tool and also the S2S4 actually start?
Hello to everybody. So S2S4 is a 3 years project that, from the official point of view, started by the end of 2017. But for me, it started in spring 2016, something like that. So at that time, we were involved in Clean for Energy. It's a Copernicus contract. Also in the development of their new Wind European Atlas that for the first time integrated the concept of climate variability. And on top of that, at that time, there were 2 interesting projects in terms of climate service. It's SPECS and Euporias that helped to pave the road for the development of the climate services.
So what did you learn from these projects that you had before that you brought into the S2S4?
The first one is that at that time, seasonal forecast was something that started to be used and to be investigated. So to understand the potential applications about seasonal forecast. And then the second one is that when you were interacting with a user, they are used to work with weather forecast or forecast for the forthcoming days. And then I was talking about next months or next seasons. And here there was like a gap. And I saw that there was a need to put together also sub-seasonal and seasonal predictions together in a seamless way.
So what you're saying is that seasonal forecasts, we have a lot of data, but then the sub-seasonal, as I understand, week 3 and 4, that's where it becomes difficult?
Well, these are different systems, and there is a need to translate all this information to the users at the end.
So, Christoph, you're actually part of this. And
Yeah.
why is this project so interesting for an energy company that you actually chose to join the project and not only, get the tool in the end?
Yeah. So good afternoon from my side. You might have recognized me as being a representative of the energy company here. Getting to your question, I mean, it's definitely no big news that weather has a large impact on our energy business. There has always been some demand-driven impact, and with ongoing growth of renewable installations, this impact will definitely increasing. It is decreasing, and it will decrease for several years and decades. And of course, I can tell you, being a meteorologist on a big trading floor is a rather exciting job at the moment, and that is because every single weather change really directly translates into a different market situation, and that's why these energy markets follow every weather forecast with a close eye, I would say. In recent years, there has been a lot of effort regarding short-term forecasts and short-term weather-related products for the energy business, for energy trading. But energy trading and especially risk management is really not restricted to these short time scales, to the next days or maybe to the next week, but covers the total range of starting from the next hours ahead until the next years ahead. So there's basically a need for longer term products. And having said this, there has been a lot of effort from scientists which are consistently pushing and exploring the limits of long-range weather forecasting, but applying this knowledge into a decision-making process is rather difficult, and it really requires a close collaboration with, on the one hand, the scientists, and on the other hand, the final users, which is our part in the project. And that is what we do within S2S4E, and we really are quite happy to be involved here to give some insights into the end user needs, I would say.
So, Albert, now that you hear what Christopher is saying, could you explain us a little bit more on what we are actually, or what S2S4E is actually all about?
Yes. So usually when we talk about climate, we always think about long term. So that by the end of the century, temperature it's going to be somehow between 1.5 or 2.5 increase. But besides this trend, so we also have climate variability. Okay, and climate predictions, putting together subseasonal and seasonal predictions, have increased a lot in the last decade. And now it's the moment to work with this data because they can provide useful information for decision-making process. But at the same time, it has some challenges because this data, it's not easy to handle with all this amount of data. You have to post-process it, and you have to adapt to the final users. Okay, so that's why we define it as S2S4E, because at the end it's to cover this gap between the research and the final user.
And Isa, you're here as a science communication expert. How do we actually ensure that we will reach society and also the relevant actors in a project like this?
Well, I think basically it's about giving time and money for user engagement in the project. So it's very common that we focus so much in the part of research, and we forget that the perspective of climate scientists is not the same as the perspective from people from the energy sector. And on my way of thinking, it's not only about energy, it's also about agriculture, insurance. There are many sectors that could benefit from this. So basically, it's about taking into account in the projects that we really need to engage in a dialogue with energy companies, understanding and putting together scientists and relevant sectors, people talking together and facilitate it. And that's why in this project we have these communication experts, environmental economists, designers. I mean, we have very different profiles because we want to engage in a dialogue, not just doing something and push it forward, say, nice tool, use it, but maybe it's not useful for them.
So one of the most concrete then results is this online tool. Could you tell us a little bit more about why you chose an online tool?
Mm-hmm. Yeah, there are many formats to provide climate services or for providing information. So if we are talking about water management, for example, maybe the best format to provide this forecast is just making one meeting every 3 months and provide information. But as Albert was saying, we start and we come from previous projects. And in the previous project, we were working in a project specifically, and it was a semi-operational prototype that was called Project Tuco. And we learned a lot of things. It was semi-operational, so it really didn't provide something useful for the users, but it makes a huge difference in what we learned from users. So we were showing to a colleague of Christoph, we were showing to other energy people, and they were saying, okay, the tool is nice, it's not useful at all, but I would like to see these, I would like you to change these, I don't like the background color. So it really engaged us, and we saw that the potential of having a tool. When you have a tool, when you have something physical to show, then it is much more easy to get something that is really relevant for you, for the energy users or agriculture.
Yeah, well, then I would like to get Matthew into the conversation, because Matthew, this is not the only tool that is in the market. And I know that you did a market study in the beginning of this project. How did you see then the need for a new tool?
So basically, yes. During the launch of the projects, we try to have like the input from the users, so user engagement, but we try also to develop something based on input from the markets. And so as every time you launch an innovation, you need to know what people, like the users, want to have, but also who are the competitors, what is the markets. Basically, we realized that, and this is exactly what Christoph and Albert just said before, if you look for tools for provision for weather forecasts, so for D1 to D15, you're going to find a bunch of tools. And if you look for climate prediction, so a statistic approach, you're going to also find data. But as soon as you start looking for tools for specific, like either seasonal or sub-seasonal, or even both, you realize that there is only a few tools. So for this specific time horizon, we realized that actually there is a huge gap between the short term and the long term. This is the first point, and this is where I think even if there are tools on the market, this is where our tool will do a difference. And the second one is the most interesting from my point of view. If you look for those specific tools for the seasonal, sub-seasonal forecast, then most of them, they're advertised for the energy market. So you will see like you are a DSO, you are a TSO, you're energy producers, this tool is done for your specific issues. And you realize that actually if you start going into the tools, there's actually only like tools that could be applied to any specific market, or any market actually. They're providing climate information, so wind speed, you're going to have like solar radiations. And this is where the product here goes further. We provide energy indicators. And so we were talking about translation, giving the information to the users. And some users are interested in the climate data, of course. But there are some users that either don't have the knowledge to translate those climate data in energy indicators, or don't have the time to do it. And this is where we provide an information that could be used directly for decision making.
Okay, so when I hear you speak now, I would like to give the floor back to Albert. And Albert, could you maybe give us like the 4 main features that you think that this decision support tool has that others maybe is lacking?
I think that this tool has some added values that all together are important. Like, yeah, it's a global system, and then we have some detailed information for Europe. Also, we integrate the energy indicator, so we provide information not only about wind, but also wind capacity factor. But on top of that, I think that the main added value of this tool is that it has been co-developed from the industrial partners and also putting together the key academic partners. And we have done a huge effort to put the science inside this tool. For instance, we have done a huge effort to include the concept of the skill, so it's the performance of the simulations. And yeah, I think that these are the main ones. And something else that now that we are starting now to play with the tool, I see it also as an interesting tool to learn, not only for the users, but also for us. We are learning a lot because now you have the capacity to have a global perspective, to go to a specific region, to change of variables, to see the different forecasts, the lead time, sorry. And yeah, for us it's an interesting tool because we are used to work with images, and now we have a tool with a massive amount of data to play with it.
Christoph, I guess that you have, been looking at the tool. What
Sure.
kind of energy trading and benefits of using this do you see?
I mean, weather services are not very new to the energy market, as said by Mathieu and also Albert before. But having said this, state-of-the-art weather forecasting is definitely key for success for the energy business. I can give you some numbers on this. Last year in Germany, 2018, it has been the first time that for a total year, renewable power, the share of renewable power in the net Germany power production has increased above 40%. And this year in March, we saw a week where this share came up to 65%. So for being a energy business or in power utility especially, there's of course a lot of weather risk, but also a lot of weather challenge in the market. And we are of course very excited to have this product at hand. I mean, we are well aware that it will never be possible physically to predict the weather in detail for the next month or even beyond, that's for sure. But the energy trading business or the energy business as total, and that might be a bit different from other target groups here, is quite used to deal with these kind of statistics if they are presented in a proper way. And I'm really quite hopefully that the project guarantees this, and that we will see a very valuable tool here in the next.
Thank you, and that's basically bringing me back to Isa, because Isa, developing a tool like this couldn't be just, it's not a walk in the park. It's not like you just go in one morning and say, let's build a tool, and then you build it, and then you're done. Could you tell us a little bit more about the tool and the development of the tool?
Well, basically, as you say, it's really a challenge, and it's almost impossible to believe how many people and how many different profiles have to be involved. From like 5 research institutions, so really different people knowing about it. Then there's a whole department of IT people that they are experts in front-end developing, back-end developing. It's kind of a nightmare. I mean, people knowing a bit about climate. I mean, climate information, climate data is not just something that you have in a pen drive. So how you deal with that so the workflow is fast, so you have an interface that reacts at an acceptable speed, all this is a challenge. And also on the design side, really getting all this dialogue with users, then you have to do something with that. You cannot just be talking with users and then develop what you want. So trying to understand which were the key aspects they wanted to see in the interface and finding design solutions to give this information in an intuitive way. I mean, I think it has been kind of challenging. But if I can say, I mean, the next challenge is like, now we are in month 18, so we have been working for 18 months, like hiring a lot, but then we have 18 months of operational working of the tool, which it is also the next part of the challenge. It's not going to be easy either.
That brings me to you, Matthew. What will happen to the tool after the project is actually ending? And at least now in the next 2 years?
All right, so we know that we have a beta version today. This is from the technical part, and usually I'm saying that my role in the project is to bring a lab success to a commercial success. When you have an innovation, and you have often in research projects people developing fantastic tools or methods or processes and knowledge, and at the end of the day it stays in the lab, and so that's what we're trying to do to ensure that we will do something with all the results. And we already started, so often in such projects people start talking about like commercialization, business aspects at the end of the project. And we already had like a full process started 6 months ago, where we had individual interviews with all the partners. We had this morning a 4-hour session all together to define how we will use this tool, like not use, but like commercialize it, have a sustainable exploitation. So are we going to have this tool soon? For me, it's a yes, otherwise it's going to fail for me. So the end of the project is 2020, and hopefully we're going to have something on the markets quickly.
And Isa, this is, yeah. I'm so glad we're making people happy. Isa, there's a reason why we call this a beta, right? And that's linked to what Matthew is now saying.
Yeah, it's linked to these 18 months of operational. It gives us room to learn about what we have been doing. And we have been interacting with the 3 main energy partners in the consortium, and we have been having some face-to-face meetings with other energy users, but we really need to open this to the community, to the whole energy community, and we really need inputs. And we know that it's almost impossible that we do it perfectly. I mean, we already know that there are some issues that we wanted to be strict with the launch, so we are launching it, it is working, but of course there are many issues, many things that we know we have to fix, and especially also to improve, because over these 18 months we're going to find out not only bugs, things that we can fix, but new functionalities that we didn't even thought about it. So if they are small, maybe we are lucky and then we can implement it. Other ones we will need to report, but at least we'll have all this feedback, so the next project that comes into it will be able to luckily learn about it. And if it's a commercial tool, even better. I mean, then they will have something additional, because now what we are launching is free. And yeah, if it becomes a product, it's good that it has added value.
So Albert, are you now then looking for beta users?
Yes, as we were saying, so yeah, we tried to go really fast during the first half of the project to have a beta version ready. And now it's the time to test it and to learn from it. So it's open to everybody through a registration. So yeah, we hope some comments and yeah.
Okay, I guess that, and thank you to all the 4 of you. I guess that there might be some people with questions now in the audience. Oh.
Just have one
Yes,
comment.
please,
It's
of course.
a hot topic because we're talking about the tool today as a nice to have tool to make reduce risks, for instance, for energy providers. Last week, I think it was Friday, the European Commission, the Council adopted the new directive, the last directive for the new energy package, so the clean energy for all European. And there is one directive for energy supply. And if you look to Article 8 and 9, they're actually talking about seasonal forecast, sorry. And the NSOE, so the European bosses of the TSOs in Europe, has the obligation to propose a methodology for to do seasonal forecasts with a probabilistic approach and to forecast the production of renewables and the demand. And basically this is something that will have to be done by all TSOs in Europe, and this is exactly what the tool is currently doing. So it's not only nice to have to improve the business, but it's also something which is getting into the regulation.
That's great. Should we give them an applause? Then I'll open the floor if anybody has questions for the people up here, or comments. Yes.
Thank you. Well, first of all, I'm a big fan of this project because I think it was very ambitious from the beginning, and I'm quite excited to see this tool. By the way, my question is a bit more about the concept behind the project. I mean, you're working in close contact with companies because you are both partners, differently from the past. And I want to see something from the knowledge management side, because you both, so I mean, you are the company, sorry, but you are there, you are personally in the company, and the climate science community, you both know a lot of things, right? But I was wondering if during this project you came up with also some thoughts about ideas on how to make possible to manage, to make accessible this knowledge that is produced in different environments to both the communities. I mean, because the role of knowledge, the point in knowledge management is to make accessible the knowledge you have developed in your company or your society, in your institution, and to make use of it, to make everyone aware of what you know. So I was wondering if you had any thought on this, because I think this is exactly the project that could help to improve this way of doing research.
I can say, I mean, maybe it doesn't answer, it's not the right answer, I don't have it, but so far, basically, this has been done through clustering different European projects working together. So most of the projects doing climate services and funded by H2020, we are in a network, we know about each other, and the good part is some of us, we are working on energy, but some others are working on the Arctic, and others are working on agriculture. So there's this common knowledge. Whatever works in one of the projects is somehow permeating to the other ones. But this is like, the problem of this is all devoted of the people in each of these projects. So I don't think there's something more stable to sustain this.
Well, I think that we are doing a huge effort also to disseminate the projects, not only in the climate community, but also in user-oriented workshops. So for instance, we presented the project in Wind Europe 2 months ago in Bilbao. So it's in the sense of, for us, we are not comfortable going to a big event like that, many people selling things, but for us it was important to go there and to present the project in front of the whole audience. So maybe this is a way also to do this link.
Any comments from the other two of you?
I mean, regarding the company side, it is of course important to state that the knowledge created here is always somehow binded to the weather and climate connection here. So we're not intended to explain the energy business as a total, or energy trading in total within this project. This would be far beyond the scope of this project. But regarding the weather relation, I would say there are also some public deliverables which might attract some interest, or might be interesting to read. So I just can invite you to have a closer look at the website.
Anyone else? Oh, there's a question down there. Oh, and one over there afterwards. Yeah.
I'll start? Yeah. Yeah, sure. My name is Berta Matasque. I'm a senior researcher at SINTEF, a research institute back home in Norway. Just a question. So I've seen that you mainly focus on solar, wind, and hydropower, as far as I understood, and energy demand. But actually, energy goes beyond that. It's not about power, it's also about heating and cooling. Now, in this respect, then, is bioenergy by far the largest renewable energy. How are you taking into account that element? And also the fact that, obviously, we know that, as maybe second question, if I may, so the energy mix varies, or it's going to vary tremendously depending on the geographic, let's say, location across Europe. So how are you taking into account those elements? I guess the data do that, but we see also these predictions changing across Europe. So how are you then planning to consider these elements? Thank you.
Regarding the first question, so so at the end, the whole energy sector is affected by many things, but here we are working with seasonal and sub-seasonal, so with climate predictions, and the scale of these predictions it's quite low compared to weather forecasts. So it's so we focus on those sectors that are more affected. So it's in terms of trying to put to the renewable supply and the demand, and we focus on that. So in this project we don't take into account like bioenergy and these things, because I don't know how to put it together.
Yeah, and also being part of the team that does this user engagement and this conversation, it takes many years to really understand a decision-making process. I mean, it is even still difficult for me to understand hedging and how this risk management in the energy market, and it's only that. And I still have troubles to understand all the implications. So if you have to spread a lot all the parts of the energy that you want to cover, then you have the risk of being too superficial, that you cannot really do something that is meaningful. And I think this is also a reason for us to be targeting very specifically one part of the energy system.
Yes, I guess that was it. We had a question over there. Oh, two actually.
Hello, I'm Gilles Cano from Vortex. Hello, Albert, Isadora. Nice to meet you. Nice to see you here in Brussels. I have few technical questions, but I will ask later on. So, I have a more business question. Have you assessed is the industry, the wind industry, for instance, is willing to pay for seasonal forecast? And if you know how much, and if you know how much they pay for the short-term forecast?
So,
it's serious.
yeah. So I'm going to start with the second questions. I can't tell you. They won't tell me neither, basically. I'm responsible for defining a price for the tool. It's part of the job. So if you ask the partners into the project, they will, of course, ask for a cheaper tool. And also, if you ask for any energy player or any sector, they will never tell you this information like straight away. This is the first, for the second question. For the first question, actually, this is something we're working on it. That's what you actually doing currently, with also some partners from a company, is defining the economic impact of the tool on existing decisions within the energy sector. So this is not exactly what you're asking, but we'll be able to have an estimation on how the tool could save or reduce risks and or improve unlocked opportunities, and how much more or less which impact it could have on the different stakeholders. So into the project is more energy providers, but we also had interviews TSOs, DSOs to do the same work. But now you will.
Yeah. Yeah. I also take the chance to comment on this. You see that there is basically major interest in this topic because simply of the fact that 3 of the companies are involved in this project and spent time on it. But of course, the question on the amount of money we were willing to spend is of course related to the quality of the final product. And yeah, we will see, I would say.
Then we had another question from you over there.
Good afternoon, I'm Josep Maria from Metosim. I'm the coordinator of VISCA project, which is building a climate service also and decision support system for the wine sector. And then I'm very interested to know about the decision-making process, because as far as we know, the sub-seasonal and seasonal forecasts have an uncertainty, right? And decision-making in this deep uncertainty environment must be not so easy, right? Then I don't know if you could give some examples of decisions you can make, but even knowing that there is a large uncertainty in the data you are considering. Yeah, that's a question.
I mean, that is a big question. I can tell you that energy trading is something different to a lot of other fields of application of this information, I would say, because there's not one one decision you take. There are hundreds of them, even more. I would say thousands or millions. I don't know. So it might be a bit easier, from my point of view, to adapt these decision-making processes into the energy business compared to other business. But yeah, that's just my very personal point of view.
I may add on the interviews we've done during the project. So the first part was the user involvement, and part of the questions were to understand how they make decisions and how they use climate data, or also where the data within the decisions, which type of data, the way they were using it, like qualitatively, quantitatively, and try to define a list of actions or decisions they're taking on such data. I think the deliverable is confidential, so I can't really...
It's public.
Okay.
The one about the decision model.
Yes. All right, so there is a deliverable you could find on the website. There are, if I remember well, there are like, I don't know, 20 decisions we listed. So it doesn't mean that's an exhaustive list, but it's basically all the decisions, the stakeholders we met, so DSOs, TSOs, energy providers or retailers, producers, and also energy traders. this is the decision we work on with him. So you have a short, quick list already.
If I can point, there is some QRs, so if you can scan them, I mean, you can go directly to the website or scan them, so you will have the list of deliverables, and that specific one is deliverable 2.1. There was a first assessment of all the efforts in FP7 and H2020 projects, a bit of what we learned about user needs in energy about this, and then there is this meta-analysis of user needs through these interviews. And there is a part that LGI was involved in about decision maps, so they were fine.
Oh, there's another one in the end. I think that will be the last question that we have time for.
Hello, good afternoon. My name is Petra. I work for JPI Climate. We are a research funding organization, and we have a major program on climate services with 26 projects, and I know, Isa, you know about the projects. It's just to say all the efforts of having insights into this decision-making, developing tools, a lot of projects are going in this direction. I just wanted to, it's not a question, I just wanted to say that the project Clim to Power, for example, is also a project looking into support for companies targeting companies not only or energy sector, not only in the renewable sector. They have and they work. I think that is quite interesting. They have a user board with which they work with, so they have a variety of companies that are giving insights into this. Into the process, and I think that's very interesting to see and to scope for the various projects now going on beyond the analysis of what has been going on. And I know your project was also presented at an event we did 2 weeks ago at the ACCA conference, and I think the exchange is very interesting to see what is going on in the landscape and which direction that takes.
Yes, I think you...
somehow we try to be in contact with all the projects that are now on the table. So for instance, in Clim to Power, I am aware of it, so I'm somehow involved in the project as external advisory board of the project, but for sure that any recommendation, it will be perfect. And also Sophia, it's the PI of Clim to Power, it's our external advisory board too. So.
And I guess Isa, that, or any of you, that all users have different needs, don't they?
Yeah, sure. I mean, there's no one tool for all, that for sure.
Okay, I would like to thank the 4 people who's been up here now talking to you all. I guess you might be interested to see the tool very soon, but I think we'll give them a round of applause. So, we would now like to actually show you the tool. And as we said before, this is the beta version because, again, we would like to introduce it in the middle of the project, so there's time and money and effort to try to make the best tool possible. And now, give me 2 seconds, because I have then to do a small technical... To get you a small video about it. just showing the video about the project. I guess you would like to actually see the tool itself. To make sure that we will be able to show the tool, I would now, soon, as long as he can, rewire the computers, introduce you Lorenz Ledo. He's a researcher at BC3 as well, where he studies the impact of weather and climate variability in the energy sector, with a focus on applications of seasonal predictions for wind power. And Lorenz, I think I'll give the floor to you, and you will actually take us through the tool. And as always, be patient if something happened with the network, because that's outside our, power, to put it that way. So, but Lorenz, I'll give the floor to you.
Thank you, Astrid. Good afternoon, everyone. First of all, I want to start with the picture of all the consortia. Isadora already said that to build this DST takes a huge work that is behind scenes that you cannot see. There's a lot of people that contributed to this work that is not in this room, and I want to acknowledge them, first of all. Then, as a provocation before playing, I want to show a couple of images. This graph that you have here is the sea ice, the Arctic sea ice anomalies for, the Arctic sea ice values for June 2019. You can see that they are quite low compared to the mean. This is, of course, related to climate change, but maybe you can imagine how this could be affecting weather circulation, atmospheric circulation in the coming weeks and months. Then I also want to show this plot of sea surface temperature. This is from yesterday, I think, and, well, you cannot see the colors very well, but this region in the Black Sea, it's more than 4 degrees above its normal state, its average. And we will come back to that later, but maybe you can start thinking if that has any relationship to what will happen in the next weeks and months in our planet. Okay, let's go to the fun, to the DST. When you go to the website address, you will find this welcome page with some information on the tool and so on. You can register, and then you can log in here. We will use my credentials, and boom, we have a map. The first thing that we will do is we will go to Brussels. So I'll search Brussels here on the bar, and I center the map on Brussels. Then I will select here on the variables list. We have a list of variables that we know that impact the energy sector, and as well we have the energy indicators, but those are not yet ready. Let's start with temperature. Then we need to select the forecast date. So we will select the last forecast that were issued last Thursday. So it was 13th of June. And when we select this day, we see that we have a map, a mysterious map with some circles. Then here on the bar that you have here above, we have the sub-seasonal forecasts for the next 4 weeks, and the seasonal forecasts for the next 3 months. Sorry. So the changing here will change the forecasts, the maps. Then the sub-seasonal forecasts are indeed forecasts of weekly average temperature, and the seasonal forecasts are monthly average values that we are forecasting. Okay. So you will not find the temperature for the day of your birthday next month. You only can find the average for the month. Yeah, also it's important to stress the weeks. We count the weeks always from Monday, so this first week is the week starting on the first Monday after the 13th, so this is indeed 17th to 23, so the current week that we are now. And the subsequent weeks and the months, they start on the 1st. So this would be forecasts for July, for August, and for September. Okay. Then if we want to understand what we have on the map, maybe the first thing that we can do is open the legend and read it. We have on red above, and in blue below, and in gray normal. So this means that we color the areas where we think that there is high probability of above normal conditions, or below normal conditions. And how can we know that there will be normal, above normal, or below normal conditions? Well, because we use models. We use climate models to do that. For the subseasonal timescales, we employ the NCEP CFSV2. And for the seasonal, we employ the European Center System 5. Those are like state-of-the-art models for subseasonal and seasonal prediction. And those models are ensemble prediction systems. And what does that mean? It means that they are run several times with slightly different initial conditions. And then we get an ensemble of equally plausible results or conditions. And then from this set, we can infer some characteristics. We can see the distribution of these different answers. We can click on a point here, and maybe I can give more indication with the detailed panel that appears here on the right. You have the temperature that we selected, the week, and the dates that correspond to the week. And here below, you can see a distribution of values. So all those values are all the ensemble members of the NCEP CFSV2 model. And you can see that we have colored them in red, gray, or blue according to the range of values of high, medium, and low values. And then if we count how many members predict high, normal, or low conditions, we derive this probabilistic forecast. So in this tool, you will not find deterministic temperature average, value. You will find only probabilities of falling in above normal, normal, or below normal categories. Let me check my plot. Yeah. Okay. Then another thing that is important is when we present forecasts, it's always present its quality, and it's what we have here, the skill. In this case, we are to check the quality of probability, so it's quite complicated. We employ a metric that we call RPSS. It's complicated math, but the thing is, this number indicates the enhancement over a baseline prediction, which is the climatology. And climatology would be just to say that those three conditions are equally likely and have 33% of probability each one. So what we do is, of course, we still don't know how this prediction for this week is going to be, because the week is not over and we don't know the values. So what we do is we look at the predictions of the model for the past years, and we assess its quality in the past. And this number is an indication. Okay? Yeah, so here on the left, you have in the tool, you have the settings panel where you can tweak a little bit the visualization. And there is a slider here that is a filter for the skill. So if you only want to show the values of the probability for places that have a good skill, you can move the threshold, let's say 30%, for instance. And you see that we removed some points. If you increase too much the thresholds, you will end up with nothing. You have also the option of viewing everything, which will show even places where there is negative skill. You see that there is a small point appearing down. Okay, now I want to go back to the Black Sea sea surface temperatures. Do you remember they were quite high? Let's go to the seasonal forecasts in that region and see what the tool says. Okay, so those are the forecasts for August. You can see it's all red. It's indicating high probabilities of above normal conditions. Indeed, in this region on the east shore of Romania. For August, we expect 65% of probabilities of being above normal. For July, it's 67% above normal, and for September, still 41%. So maybe what is happening here is that the models predict that the sea surface temperature will persist through the summer, And these temperatures in the sea will have an impact on the air temperature at the end. So you see, this is a very classical driver of variability. We have a climate component, the ocean, that is forcing the atmosphere. And in this case, it's quite obvious. The sea surface temperature impacts the temperature of the air. For other drivers, as I showed before, the sea ice extent in the Arctic, maybe you think that this is too far from here to impact the climate here, but I believe it is not too far. However, we still don't know exactly how this happens, and we need to better understand climate in order to see what's going on here. Another thing that we can do with the visualization is, I have not talked about that, but you see that there are small cycles and big cycles. The small cycles are those that have less than 50% of probability to occur, while the big cycles have more than 50% of probability of occur. So in some sense, this gives more visual importance to the areas where there is a high probability of above normal conditions. And then what we can do is change this threshold and move it to 60, and then you see that the legend changes, and we will see less big circles. Yeah, and okay, this is the only point in the Black Sea where the probability is above 75%, you see? Then I want to move to another variable. Let's go to look at wind speed now. Okay, we select wind speed on the bar. I will set this back to reasonable values, 60%. And we go to Portugal. This is, I want to see the forecast for August, and we see that the models, the System 5 model is predicting above normal conditions with a 75% of probability and 0 in the below normal category. This is quite surprising for a 2 months ahead forecast. And if you look at the distribution of values, you will see that even the high values are quite high in the distribution. So indeed, what we have here in the panel, in the forecast panel, is this extremes forecast. It displays the probabilities that the wind speed exceeds the percentile 90, or that is below the percentile 10. So extremely high winds or extremely low winds. And those forecasts are accompanied with its quality estimates here. You cannot see very well, but it's 18% for the minimum and less than 0, so it's a negative scale for the max. So in this case, in this point, we have 31% of probability of above P90, so it's like 3 times more probability of having an extreme wind event. But the scale is negative, so we have to take this forecast very carefully. I mean, in the past, those forecasts did not work well, okay? Is it clear? Another thing that we can do with the visualization is it's related to the extremes prediction. It's display areas where the models predict extreme winds. And you can see these triangles depict areas where the distribution of values has a lot of probability above or below the P90. Here the same, but for below conditions. What else? We can also go and look for past events. So for instance, last summer was quite still in Europe regarding wind speeds. And if we look at the forecasts for August last year, we see that in Spain we see blue colors indicating below normal, high probabilities of below normal conditions, and also some extremes in some points. And you might argue that the skill is not very good, but indeed it's not that bad. I mean, 10% of a skill for a seasonal forecast is not neglectable, I would say. Of course, what you do with this information is something that I think has still to be explored further, but yeah, we have potential. Another thing that is available on the tool, it's drawing country averages. For instance, we can say we can look at the same event, but look at the country averages of wind speed, for instance, here, and we see the same thing that we were looking. I have to say that if you look at country averages for the subseasonal timescales, you might encounter some problems. So I advise not to use the country averages yet, because we are fixing things in the tool. Yeah. Finally, as a funny provocation, I want to show subseasonal forecasts of temperature with the extremes for 2019. And look here, what happens is a curious thing. We have both high probabilities of above normal temperatures or below normal temperatures for this week in the Black Sea, 2 points of the Black Sea. If you click at the point, I get the distribution, you will see what's happening here. We have a lot of members above normal and a lot of members below and very few normal. And what would happen here if you look at the ensemble mean forecast, something that is quite common, I would say, in the products that are available nowadays, you would get like a central value that is very unlikely. So yeah, using the ensemble means from this climate prediction model is always dangerous, as this illustrates. There is much more things to play. There is an extended panel, but I maybe prefer to not go into more detail. I think I bothered you a lot. And we can go to the hands-on and you try the tool. And if you have questions, I think there is time for a few questions now. Right, Astrid?
Yes. Thank you. And also one of the few events where I've been to where nothing bad happened to the technical side on the way. Does any of you have overall questions for Lawrence? There will be time to talk to several of you after.
Nobody has questions.
It's initially very good news. Yes.
As you said, the tool is still in development, and there will be new features added in the coming months. Probably you could say a few words about the energy variables in particular, which will be available and so on.
Yeah. Okay. Yeah. First of all, I forgot to mention that those forecasts are going to be live. So every Thursday we will be updating the subseasonal forecasts, and once per month we will be updating the seasonal. They are updated around the 15th of each month, more or less. Yeah, so it's fun. I encourage you to go there and play. It's really fun. Albert said it. We are learning a lot from seeing the forecast that we used to see in maps in a tool that you can click, see what happens very fast, and get all the details. Then Laurent's question. You were asking about indicators. So yeah, the indicators that we plan to use. So here you can. There is a category or grouping of variables, and you can see wind, solar, hydropower, or energy balance, and then if you go to solar energy, you will see the variables that you have available, and you have solar radiation country, and you have capacity factor, which is grayed out here because it's not yet available. So we have capacity factors for solar and for wind. We have demand for countries, and for hydro, I should check it because I'm not an expert, but we have inflow from river catchments, so it will be aggregated over river catchments, and annual snow max anomaly. Yeah.
Thank you. Any other questions for now? Yes.
Thank you. I suppose you would also you launch it now, and then you promote it, so you have an idea of who would use it, or can you trace that at some point? And especially, is there feedback requested from the users so that you can improve it based on the feedback from the users you have? Maybe
Well,
you've said that when I was outside.
I am not the right person to answer the question, but maybe Isabel can answer it later better. But as far as I know, we are like now opening the tool for anybody who basically wants to use it, but we would like to receive feedback in turn. And, well, yeah, Isa.
I invited Isa back up because she knows this.
I know it. It's like my child. So basically, one of these things that way we call it beta is we're really missing. There will be a link up there beside the user to make it easier for anybody using the tool to provide us feedback. Until we don't have that link available, it will be a matter of 1 to 2 weeks. Anybody can write to the general email of the project providing feedback. So yeah, it's really important for us, for anybody to give us feedback on new functionalities or problems they encounter, whatever they. And then I wanted to add something, just that because it's a beta, we cannot have everything working right now after. There are these two functionalities that they have been very much requested for any user in energy, but in agriculture everywhere, which is the data. Data is at the core of all the activities. It's very nice to have an interface, but we know that after the interface, people want to have the raw data, whatever it means. So we have that in mind. So this beta version is going to have some updates, and there is going to be this option to download data. So it's the processed data, it's not the data that you can get from the climate data store. It is something that is improved for the energy sector, but it will be available to be downloaded here. But downloading data, it takes a lot of technical challenges, and we are still solving them. And then if you can open the detail panel.
Mm-hmm.
You have to move to seasonal, maybe.
I don't think so.
Okay. And if you go down, scroll down here, there is this option for download report. So basically, we are going to be providing some outlooks. Every month, we will be providing in the website some PDFs showing a general analysis of how the forecast is expected to be for the coming weeks and months. And there's going to be a bit of the analysis of what has happened in the last month. So it's really for people to be able, the performance of the tool. And so there will be, is it climate service? And the climate service can be much more than just an interface. It's also about having a lot of scientists working together in this project, having a budget over the next 18 months to be interacting with people and answering questions.
Thank you, Isa. And I guess you had...
Yeah, I just want to add one small thing is that you have here on the left the guided tour that will open and maybe be a better guide than myself, more organized. And you have also the advanced information, which gives all the details on how we get the data, how we transform it, how we compute everything, and reference of scientific details. Yeah.
Thank you so much, Lawrence. And to make sure that all of you that might have questions or want to look into the technical details and so on, we will have continue this session with different groups where you could actually talk to people. But before we do that, I would just like to stress the fact that we would love that as many of you as possible go in, play with the tool, because our goal in this project is to create the best tool there is. And we acknowledge the fact that the only way to create the best tool there is to actually listen and get feedback from all those people who want to use or have the possibility to use this tool in the future. So it's really, really important for us, and that's also, as we said earlier, why we are launching it as a beta version. And as Isa said, not all features are still in place, and there might be new ones. And the version you saw now might actually also have slightly different, interface, slightly different buttons to push on when we get all the feedbacks from the users throughout the next 18 months. But in order to get you all organized, and I know for a fact that there is some small food and some drinks outside, but in order to get you organized, I would like to give the floor to Asun, who will tell you a little bit more about the now upcoming hands-on session. But from my side, thank you so much for joining us.
Thank you. So as Astrid was saying, now it's moment to stretch our legs. You can grab something to drink and to eat that will be in the lobby. You can also maybe go outside and get a little bit of fresh air. But basically what we are going to do is we will have 4 stands. You can have a much deeper conversation with Llorens. You have already met him. And Llorens, you will be on that corner over here. No, sorry, on that corner next to the piano. So next to the piano, you can ask Llorens all the detailed questions. Then we will also have partners in the project, Carla and Joan Miguel. Carla and Joan Miguel, they're here, okay. They are partners in the project, and they are the ones working on commercializing and putting this tool into the market. So if you want to talk about commercialization, go talk to them, and you will be sitting over there. Oh, I didn't know I had that. Very good. And then we will also have Ilaria, who's sitting in the back. And you heard Isa mentioning earlier that we have done an analysis of the economic value that this tool may lead to users. So you can talk to her more about that. And if you want to have sort of systems perspective and a little bit of what happens in between business and research, you can talk to me. Okay? So now I welcome you to grab something to eat and something to drink, and we have this room booked until 4 o'clock, so there is plenty of time for these conversations. All right?